All right, so we're going to dive into payment processing, like how to build a system that just works. Smooth, like a credit card swipe, but without the code turning into a total nightmare. I mean, you start out thinking, okay, credit cards, maybe PayPal, but then boom, mobile wallets, crypto, and who knows what else, and suddenly your code's like, help me.
Yeah, that's when things get really complicated. A lot of people, they start with inheritance, right, to structure their payments. But that can turn into a coding nightmare, especially with all the new payment methods popping up all the time.
Yeah, that's what we're going to figure out today, how to sidestep that inheritance headache and build a system that can handle anything. And to help us with that, we've got our expert here.
Glad to be here. I think a good place to start is, well, why does inheritance fall apart in this situation?
Okay, so I'm starting out and I'm like, inheritance, great. I've got this payment parent class, and then I can just make child classes for credit card payment, PayPal payment, and all that. What's wrong with that?
Think about it like this. Digital wallets, like Apple Pay or Google Pay, they use both credit cards and bank accounts. So how do you fit that into inheritance, where a child class can only have one parent? It just doesn't work very well.
Ah, like trying to fit a square peg in a round hole, never good with code.
Exactly. And even if you kind of force it, you end up with code that's fragile, breaks easily. Every time there's a new payment method or something changes, you could break the whole system.
Yikes. Not good when you're dealing with money.
That's where interfaces come in. They're way more flexible. Instead of parent-child stuff, they're like a contract. All payment types have to follow the rules.
Like setting the ground rules, right? No matter what kind of payment, they got to follow the rules.
Exactly. Like in this code, they have a payment interface. It says each payment type needs a process method. So every type, credit card, PayPal, whatever, it knows how to process a payment.
So like process is the universal language. They all got to speak it.
Yeah, that's a good way to put it. And that's where interfaces really shine.
Okay, tell me more. How does this make the code better?
So there's this payment service class. It's the part that actually processes the payments, right? It only works with a payment interface, so it doesn't care what kind of payment it is.
So it's like, hey, I don't care if you're a credit card or a carrier pigeon, as long as you can process yourself, we're good.
Exactly. That's what makes it adaptable. If there's a new payment method, no problem. As long as it implements the payment interface and has that process method, the payment service can handle it.
Amazing. It's like future-proofing your code. No matter what new payment thing comes along, you're ready.
Exactly. But what about when different payment types have things in common, like security checks or logging stuff? You don't want to write that code over and over, right?
No way. That sounds like a recipe for disaster. So what do we do?
Abstract classes, they're like a blueprint with some parts already filled in. They have abstract methods like the contracts from the interface, but also concrete methods, which are shared functions.
So it's a mix, structure of an interface with pre-built stuff.
Yeah. In this code, there's an abstract payment class. It does payment validation, which is important for all payments. Credit card payment and PAL payment both inherit from it. So they get that validation logic for free. No extra code.
Smart. So no duplicate code, and important stuff like validation is always done.
Exactly. Abstract classes let you define common behavior, but still leave room for each payment type to do its own thing.
Okay, so we've got interfaces for the rules and abstract classes for shared blueprints. Feels like we're building a solid foundation here.
We are. And to see these concepts in action, this code uses something called composition. Instead of only inheritance, it builds things by combining simpler objects.
Composition, that's new to me. I'm used to inheritance, so I'm curious about this. But before we get into that, can we see an example of interfaces in action just so we really get it?
Good idea. You familiar with Selenium WebDriver?
Selenium, yeah, I've heard it's great for automating web stuff.
It's a perfect example of how interfaces make things flexible. It uses the WebDriver interface to interact with all kinds of browsers. Chrome, Firefox, Safari, you name it.
Wait, so instead of writing different code for each browser, Selenium uses this WebDriver thing to talk to all of them.
Exactly. You write your automation once, and it can run on any browser that uses the WebDriver interface.
Wow, that's so cool. Like a universal remote for browsers?
Exactly. And it's the same idea with our payment system. By using an interface, we make it adaptable to anything.
Okay, I'm starting to see the big picture. Interfaces aren't just some abstract thing. They're how you build systems that are flexible and future-proof. But now I'm really curious about this composition thing. How does that fit in?
We'll dive into that next.
Yeah.
The bonus code we have. It uses interfaces, abstract classes, and this composition idea to create an even better payment system.
All right, let's see it. I'm ready for this composition magic.
So, probably wondering how composition really works, right? How is it different from inheritance? Let's look at this bonus code and see. It starts with this abstract base class called abstract payments base class.
Okay, so is this abstract payments-based class like the starting point for all our different payment types? Sort of sets the stage.
Right. It's like the basic structure of a payment method. It has this abstract method, process payments,
Mm.
which is where the actual logic for each payment type goes. But here's the interesting part. Instead of directly inheriting from this base class, the abstract payment service class, the one that handles the whole payment process, it does something different.
Ooh, suspense. What does it do?
It has an instance of that abstract payments base class as a private field. So instead of being a child class, it's more like a partner. This is what composition's all about, relationships between objects, not a strict hierarchy.
So instead of saying, I am a payment type, it's saying, I have a payment type I can work with. It's delegating, right?
Exactly. The abstract payment service doesn't care about the details of how each payment type works inside. It just uses the contract from that abstract base class and calls the right method when it needs to process a payment.
You know, this reminds me of something I was working on. I had this feature that needed to use different data sources, some databases, some APIs. I tried inheritance, and it got messy fast. I wonder if composition would have been better.
Probably. Composition is great for managing complex stuff and making code easier to change later. Think about it. You add a new payment type, you don't have to touch the abstract payment service at all. Just create a new class that follows the rules from abstract payments base class, and you're good.
Much cleaner than messing with old code every time something new comes up. It's like Legos. You just snap a new piece in, no need to rebuild everything.
Exactly. And it's not just about adding new types. Composition also makes it easier to handle different parts of the payment process. Like, remember that question about transaction fees?
Yeah. How do we handle those fees that are different for each payment?
Well, with composition, you could have a whole separate object just for figuring out fees. It could have its own methods, its own logic for how to calculate them.
So instead of putting all that fee stuff in the process payments method, we have a dedicated part for it, like a little accounting department in our payment system.
Right. And this fee object can work alongside the payment processing object. They cooperate, but they're not tied together too tightly.
Okay, I'm seeing the big picture now. We have interfaces for the rules, abstract classes for shared stuff, and then composition to connect everything in a flexible way. It's like building a well-oiled machine.
And you end up with a system that's strong, efficient, and ready for anything.
This bonus code is amazing. I can't believe how much difference composition makes.
It really shows how important it is to think differently about how objects work together. And speaking of different, there's something interesting in the bonus code. I wanted to point out the use of UPI as an example.
API, remind me what that is again.
UPI stands for Unified Payments Interface. It's a mobile payment system, really big in India. I think it's great they included it here because it shows how this code can work anywhere.
Yeah, good point. It reminds us that these ideas aren't just for a few payment types. This code could handle all kinds of payments from all over the world. Credit cards, digital wallets, even things like UPI.
Exactly. And because it uses a real-world system like UPI, it's even more relevant to people who might be building systems for different countries.
This has been awesome. We started with inheritance problems, looked at interfaces and abstract classes, and now we've seen how composition takes things to a whole new level. What's next in this deep dive? I feel like we just found buried treasure. Not gold, but something way better. We really get how to write good code now.
And this treasure map, it's not just for payments. Interfaces, abstract classes, composition, you can use them everywhere.
Yeah, it's like leveling up our coding skills. Now we can tackle anything.
Speaking of challenges, remember the transaction fees. Perfect example for comp.
Right. Have a separate thing just for calculating fees. Like our own little code accountant.
Yeah. And it can work with the abstract payment service, but they're not all tangled up together.
I love how composition breaks down big problems into smaller ones. Each part does its job, and together they make it all work.
That's what makes it so powerful. It's not just about making the code work, it's about making it good. Code that's easy to understand, change, and that can last.
So, to wrap things up, what's the one thing our listeners should take away, even if they're not working on payments?
Don't get stuck on inheritance. Try interfaces, abstract classes, composition. They'll make your code so much better.
It's like moving from a stiff hierarchy to a flexible team. Think about your problem and how these ideas can make your solution better.
And experiment. Try different things. See what works for you. Always be learning new stuff. Coding is always changing. There's always something new.
So true. This deep dive reminds us that learning never stops. There's always something new to learn and challenges to conquer. That's what makes coding fun.
Exactly. So to everyone listening, keep exploring, keep trying new things. You never know what you might find.
And if you come up with a cool way to handle those transaction fees, let us know. Share your ideas, your code, your successes, and your struggles. Because when we learn and share together, we all become better developers. Until next time, happy coding.